Everyone should have that. So that's what we're going to go through. We're going to start off with math today. And I know that on the SAT, most of you guys have already taken like Algebra 1, Algebra 2, and Geometry. That's as far as they really go. You're pre-cal now. So they barely touch on trig, but I mean, they get into a little bit of sinusoidal stuff, but not heavy on that. So what's really challenging about math on the SAT is that they really make most of their problems word problems. So they're really testing your ability to translate from sentences into math equations. So let's start off with this. This is kind of quick fire here. Should be on page 46, I think. Is it 46?
It is 58.
Oh, 58. Okay, 58. Okay. Let's go on that one. So let's start over here. Jeremy's been here early, but tell me, when you read that point right there, is 5 a factor or a multiple of 10? I saw your lips go, So it's a factor. Tell me why it's a factor. Kind of, sort of. Okay. All right, Dominic, 10 is a factor or a multiple? Can you help me get in here? Yeah, so that's okay. It's a multiple. And why is 10 a multiple of 5?
Because you can multiply 5 by 2 to get 10.
Yes. So the way to think about it is that the easiest way to remember, because a lot of us are like, I can't think of a good definition for this. It's simply this. Factor times factor equals multiple. I like to think of it as factors are parts and multiples are results. So I think of it as like this: part times part equals result. And like you were giving us 2 and 5, right? So 2 and 5 are parts of 10. 10 is a result of 2 and 5, right? That's an easy way to remember it. And that way you don't get thrown off by the wording, because a lot of these word problems, they'll purposely just write it in a sentence and assume that you will know how to translate it, and they'll do it in a way that sounds a little bit tricky, but that's kind of what they're doing. An example of that is question number 1. Emma, can you read that one and include that sentence in italics? Yeah. Read the question first and the sentence. It should be 6. 2 multiples. Okay. The sum of 2 multiples of 6 must be a multiple of 12. Okay. Okay. So what is this question really asking us to do with this sentence?
Equation.
Yeah, so we want to make an equation. What would you do with it? Do you want to try it, Emma, or does anybody want to try this? How would you translate this?
Well,
X and Y.
X plus Y.
Okay. So you're saying X plus Y. Okay. And what about equals 6? So that's okay. Think out loud. We're brainstorming out loud. That's totally what we want to do here. People can bounce the ideas in their head. Anybody else kind of bouncing that idea of how to translate this? Dominic?
Would it be 6 open parentheses X plus Y?
It can be that way. I mean, what he said is, can it look like this? Yeah, it can look like that. It can look like that. It can also look like this. Because multiples of 6 are 6 times x, whatever number it is, and 6 times y. So what's the right side of the equation going to be? It could be in any variable, n. So Jeremy says 12n. I like that because we don't know what it's going to be, right? It doesn't necessarily have to be the same variables x and y. So we have translated this correctly. But is the question asking us to fulfill this equation? Right. So where should we start for this one? We'll start with C, okay? 6 and 12. Can we use these numbers? Can we use these numbers? What do you guys think? Jeremy? Can we use these numbers? 6 and 12? That's from answer C. We can, because this is 6 times 1, this is 6 times 2, so those numbers are okay. When they add up, they give us, obviously, 18. So it equals 18. What does that tell us about this? Dominic, you have an idea? Right, so 12, so this means that C is, do we need to fulfill this?
Yeah.
No. C is the right answer. C is the right answer. Okay. I was like, okay. It was confusing because they say which of the above will prove, which of these numbers will prove that this is false. C proves that the statement is false. So that is the answer. I know that was confusing. Really quickly, just to reinforce this, just looking at answers A and B, those should be knocked out immediately. Does anybody know why I can say that immediately? Jeremy? Correct. So 3 and 9, that knocks out A and B immediately. And then D does the opposite of proving the statement is false. It proves the statement is true. So that's out. That's kind of confusing. That's why I want everyone to be on the spot with the definitions of factor and multiple. These are quick yes and no's here. Jeremy, on this side, is every multiple of 8 a multiple of 4? Oh, I was pointing on this side, but yes. It's okay, it's okay. What do you think? So you're a little bit less, you're thinking, I think so. Jeremy, on this side, you were quick to say yes. Why do you say yes immediately? Right, 4 is in 8 already. So anything that 8 is a multiple of, like 16, 24, and all that stuff, 4 will go into it. So that's a yes. Lucas, what do you think of the one right after that? Is every multiple of 4 a multiple of 8? Yes or no? Right. So obviously 4 is a multiple of 4 that 8 doesn't go into. 12 is a multiple of 4 that 8 doesn't go into. So they're both proof that not everything that 4 goes into is a multiple of 8. This is kind of just a general rule. Every positive integer is both a factor and multiple of itself. That's what they're saying with that. And part C right here, they're just reiterating there are various ways to express the exact same thing. 16 over 5 is the same as 3 and 1/5 is the same as 3.2 and 3 remainder 1. And they're just saying, just be ready to go with any of them. Here's the rule for primes here. Dominic, you want to read that for us?
Yeah. A prime number is a natural number with only 2 factors, itself and 1. 2 is the smallest prime number and the only even prime.
Okay. Emma, is 1 a prime number? Right. Good. You're not easily fooled. So that was for people who are like, yeah, I'm not really listening, but whatever, yeah. better say yes. Wrong. It is not. Okay. What I will say about the SAT is most of the time when they deal with prime numbers, they're really trying to test students to see if they remember one is not prime, two is the smallest prime. Okay. They are always trying to test to see if you remember that. Can a prime be a negative number? Correct. So she paid attention. Two is the smallest. No negative numbers. Whoever the dude was who created prime numbers, I don't know who he was. He wasn't thinking about negative numbers, or because I know students have gotten to this discussion about this. They're like, well, what if you did look at negative numbers? Because like -1 is 1 times -1. That's two separate numbers. They just weren't dealing with negatives. I don't think that was part of it. Okay, so really quickly, on point E, what's the difference between these three questions? Lucas, what do you think? Just looking at those. What's the difference between those three? They are getting more specific, yes. And in what way would you answer these three differently? Mm-hmm. Right? When you do this, I know I'm asking you all the questions, but what would be your technique of finding the factors? When you said a chart, what do you mean by a chart? Okay. Okay. Yeah, that's good. I like that. So this is, I like what he said right there for, hello. Yeah, so the reason why I asked him all these questions is Lucas is correct in saying that they get more and more specific here, because in the second question, they're really asking for just the primes. And then the third one, they're saying distinct prime. When they say distinct, that means non-repeating. So for the third question, like I'll do a tree real quick to do this. But if I had a tree and I did this and I end up with 2, 2, 3, 3, right? This is repeating 2 and 2, 3 and 3. If you answered for the second one 2 and 3, you could that would be fine. For the third one, it should be 2 and 3, but you don't need to repeat 2, 2, 3, 3 because there are 4 factors that if you multiply them together, that would equal 36. Just remember that distinct means non-repeating on that one. My question here is this. Lucas gave us, he said he was going to do it by just writing them from least to greatest. What do you guys call that? You guys have a method for what you call that? I just call it a list, right? So if I was to do the list, I want you guys to notice that you're not going to get the same numbers, right? So if you did a list, I would go 1 and 36, 2 and 18, oops, 3 and 12, 4 and 9, 6 and 6. You can see that the tree doesn't produce all the numbers that the list produces. So just to answer the first question, the tree would not be a sufficient method. You guys see that? I would only use the tree if you're looking for primes because it gets straight to the primes fast, right? I didn't have to deal with all these other numbers when I was looking for primes. Yeah, Dominic?
It was just kind of about the difference between prime factors and distinct prime factors.
Yeah.
So for what are the prime factors? You write 2, 2, 3, and 3.
You could write that, yeah. That if you said what prime factors multiply to equal 36, then it would be 2 times 2, 3 times 3, and that would equal 36. But if it just asks for distinct, then just 2 comma 3 would be the more appropriate way to answer that one.
And for the first one, where what are the prime factors of 36? Would it be 2 comma 2 comma 3 comma 3?
For that one, I would write it in a way of 2 times 2, 3 times 3, just because we know that's why you repeated it. Otherwise, usually they don't need you to say distinct to know that 2 and 3 are the prime factors of it. But if they do say distinct, then you know you're only writing one number. but I think the thing that I really wanted to drive home is in terms of like your goal, if it's to list every factor or total number of factors, do the list. If it's just to find the primes, use a tree faster, right? Let's look at number 2 here. Let's have Jeremy on this side. Your last name is Rodenberg, right? He's Rodenberg. You're Hubing. Okay, all right. Go ahead with number 2 then. Mm-hmm. Yeah, go for it. Why don't we do this? Looking at the answers, since all of them are numbers, we could back solve this one and break them down because it's asking us which of the following would not be the results, right? Do you want to break those down real quick? That might be faster. It is prime. That has to be the answer because it's saying each of the primes must be greater than 2. If they're still using 2, that would not be allowed as a number. It could not be the result. Greater than 2. All of the other ones are odd. 35 is 7 and 5. 39 is 3 and 13. 57 is 3 and 19, I think. So those are out, just like that. Okay, let's go over here. I've lost all order of who's answering what, but we'll just go to Jeremy on this side and read number 3 for us.
The last point is that I was a point in the XY coordinate for which the coordinate x and y are features. For how many lattice points in the equation is x plus 4 minus 17? I choose it.
Okay. What do you think about this one? What I will say here is don't be thrown off by this introduction of this lattice point thing. Does anybody notice why they're talking about lattice point? Yeah. What is the real purpose of that sentence? The most important thing that, Dominic, what did you want to say?
Is that both x and y are in?
Correct. That's the most important thing. They just go into this thing. It's just a piece of graph paper. That's really what they're saying. But their real emphasis is don't use decimals or fractions. That's what they're saying. So now, what do we do with this? Anyone can chime in. Dominic, what do you?
I started with I started by plugging in 4 for y and just so I essentially was solving for x
Okay.
by plugging in for y, trying to get as close as I could, and then working my way back.
And it didn't work, right?
Yeah.
Okay. Yes. Both of you arrived at the same thing. Dominic plugged in numbers, and Lucas said, hey, wait, you can't add even plus even and get odd. That's impossible. So the answer is none, because even plus even is always even, so it's none. Correct. Good. Sometimes you'll remember the number properties and you'll be like, oh yeah, that's impossible. Sometimes you'll plug and it'll verify itself for you guys and you'll come to the same conclusion. Let's go to number 4. Emma, you want to read that?
If the numbers 70 and 105 are both multiples of prime numbers, n, how many possible values are there for n?
What do you think we should do here?
I'd say plug in numbers,
For,
n,
okay. Are you just going to reach out and just grab numbers, or what would be a faster way of doing that?
that's one of the
Back solving would not work on this because you're not just dealing with 0, 1, 2, 3. What's an important piece of information from the question that tells us what technique we should use? Prime.
Yeah, maybe go back to the tree.
Tree. Thank you, Jeremy. So I would go with the tree with both of them. So you can do that with 70 and 105. What do we get here? 35 and 2. Can you keep breaking it for me? 7 and 5. Okay. Does anybody want to try 105, or does anyone know it off the top of their head? Yeah, Dominic?
21 and 5.
21 and 5. Okay, 7 and 3. How does this help us to answer this question now?
Now we can see that
Only 7?
No,
7 and 5. So that means our answer for this is 2 numbers shared. Correct. All right, good. So we had to look for keywords for us to think about what strategy to take on this question. All right, let's go with the next one. Dominic, you want to read that?
Yeah. How many positive integers less than 50 are multiple for a common?
So what do you think? Yeah, what do you think you should do here?
We'll write it out in numbers. Write out like
Sure. A list of multiples. Okay, let's do that.
okay.
Yeah, I would actually do the list with. Here's the thing. Would you do the list of 6 first or the list of 4 first? Which one would you guys do? I would do 4. Do you know why? The question is saying, which of the following are how many positive multiples of 4 but not 6? You can cross out the ones that are of 6 also. But otherwise, if you started with 6, you'd still be asking yourself, which ones are the multiples of 4? So you still need to do the list of 4. I would do 4. So go ahead and tell us what we should have here on the list. Do you want to tell us? Sure. Yeah, go for it.
Okay, so 4, 8, 12.
We'll cross them out later. Just list them. Yeah, just
8, 12, 16, 24, 28, 32, 36, 40, 44, 48.
okay. Now I would cross out the ones that are shared with 6 because they're saying which of the following are multiples of 4 but not 6. So you want to cross out those. So obviously you're going to see a trend. So it's basically that are just exclusive to 4, and then the third one, every third one is shared with 6. And once you see that, you'll know that you did it right. So your answer here is 8. So there are 8 multiples of 4 that are not shared with 6. That's how you do that one. For a written question, I would either write it to the leftmost column to start it or the rightmost column, but don't write it in the middle. Okay. Usually, if a number is greater than 4 digits or something, then you'll round the last digit. If that's like it's 3.14 and it keeps on going and stuff like that, just round it. So the fourth digit will work there. Okay. Let's turn the page. This is reinforcing our knowledge of exponents and just the rules of exponents. So I think you guys know these well, and I just want to hear how you guys would explain each of these points on point 8. Lucas, do you want to read that for us? The first one? You could just do the first one. Uh-huh. Do you want to do it that way, where you keep multiplying and multiplying? Is there, because if they gave you all answers that were not like expanded, 4 to the 5th power. So Jeremy, tell us what's the key rule that we're trying to remember on that. Right. So if they have the same base number, then you just add the exponents when they're multiplied. So yeah, that would be 4 to the 5th power. Right below that, let's go to Jeremy back here. What would you do with 3 to the 4th power? Yes, so the exponents stay the same. The base numbers get multiplied when they share the same exponent. So you got that one. Let's go Jeremy Rotenberg on this side. What do you do when you divide these? You subtract it, so this becomes 4 to the 1st power. Yeah, good. Emma, what happens when there's only one base number and it has an exponent and it's taken to a higher power? You multiply them. And so you get, for this one, 4 to the 6th power, correct. Anything taken to the 0th power equals 1, correct. Good. This next part right here, Dominic, tell us why you think they call this a classic trap.
Well, because A to B plus A to C is not for A to B plus C. Because 4 to the 3rd was squared is not equal to 4 to the 5th.
And why is that a trap?
And because it's not.
Correct. It's addition, it's not multiplication. The rules of multiplication would be, oh yeah, you can add the exponents, but for addition, you would just simply square the 4 and take 4 to the 3rd power and then add them together, which would give you a completely different number than 4 to the 5th, which is huge. Let's go to number 6. Let's have Jeremy, how do I say your last name? Hubinger? Yeah, can you read that one? What would you do first? Okay. All right. So that's 8 to the 3rd. Is that going to help you? They don't share base nor exponent, so it may not be the most. Just 4, yeah. Great. And then what do you do to get your final answer? Right. To the 5th, yeah. And just glancing at the answers on this, I think you'll be leaning more towards using 2 as your base number, so that makes more sense, right? Good job. This is just showing us a few rules with exponents and then radicals. We've already talked about exponents, but with radicals, it's basically the opposite of it. There's a couple of rules that they want to emphasize, just that when there's fractions, you can separate the radicals for the numerator and radical for the denominator. And then when there's 2 numbers multiplied inside, you can separate them into radical of the first, radical of the second. So Lucas, you want to tell us what would happen to 4/9? It would be 2 over 3, right? And then Jeremy Rotenberg, what would you do with radical 75?
Wait,
We're on point E.
oh, there. I guess I would separate it out into root 25 and root 3.
Yes. And so, yeah, you could separate those two as root 25 and root 3. So that would be 5 root 3 on that one. Emma, why is this a classic trap with radicals here? Correct. Same thing as what we saw with the exponents. When you have addition going on inside of a radical, you cannot separate them. They must be kept together. So root 4 plus root 1 doesn't equal root 5. Here's a question off just the side. I know that for some of you guys, you're like, well, I can use a calculator on the SAT. But what if in the no calculator section, they gave you things like square root of 2, square root of 3? How many of you guys actually know these numbers off the top of your head? No. It's actually worth memorizing, you know. Root 2 is 1.41, root 3 is 1.73. Some of you guys are like, really? But I mean, it's worth it just because you may run into some problems that force you to look at them. And when we look at question number 7 here, this is an example of this. Since Lucas just put that in his mouth, I'm going to ask Jeremy to read number 7 for us. So what would you do here? I'm not sure about that one, but it's just floating there. But that we can disregard that. What should we do here to solve this one? Because they're asking us which of the following equations is true or must be true. So in all situations, is that a hand up there, Jeremy? Okay, I thought it was. Dominic? Yeah, what would you choose? 1/2? Okay. You could do that. And then when you look at these answers, you're going to put 1/2 in for x, right? What would be the square root of 1/2? Unfriendly. It's going to be unfriendly. So is 1/2 the most convenient number to choose for x? What would you use on this, Lucas? If not 1/2. I'm pretending this is in the no calculator section. I'm sorry? Sure, 1/4. I wouldn't even think in decimals because it's even harder. Like, what is the square root of 0.25? You sound like a robot, right? If you could memorize it. But what would be the square root of 1/4? Which is what? Yeah, so that actually equals 1/2. Because this is 1/2 times 1/2, you can pull it out, right? So that makes it easier to compare because that's comparing it to 1/4 squared. So yeah, 1/8 is smaller, so A is out as an answer choice, right? Oh no, wait, no, that would work actually. Oh, it works. Sorry, the A works really well. Let's double check to make sure the others don't work. 1/8 is not bigger than 1, right? 1/2, so B is out.
Oh, sorry.
B doesn't work. That's 1/8. It's not greater than 1. C is 1/4 versus 1/2, right? And this is not true, so C is out. And then D is 1/16 versus 1/4, and that is also out.
But x squared was 1/8.
No, x we chose was 1/4. So if you square it, it becomes 1/16, right? B, this would be 1/16 versus 1, and that's not true, right? Oh, I'm sorry. I wrote that too fast. That's right. This is 16th. Yeah, I wrote it too fast. But that is 1/16. That's obviously A is greater than, or square 1/2 is greater than 1/16. That's what I was trying to say. But A is the only one that's true. So A is our best answer on that one. So the takeaway from that is choose numbers that are easy to deal with, right? Because sometimes, even though our natural inclination is, yeah, I know 1/2, it turns out that it's not as friendly. Okay. We're going to do this in opposite order. Let's go to number 10 here first. Let's go with Jeremy Hubinger first, number 10. Okay. Yeah, 9 is your best one because it's the only one that gives you an integer as a result. The rest of them are going to be decimals. This, you didn't have to memorize the square root of 6, 7, and 8, but you knew from probably doing this in the past, it's like, oh, those are going to come out as decimals, right? Let's go over here. Jeremy Rotenberg, you want to tell us for number 9, what would you do here?
All right. If n equals 3 cubed, all expressions equals that 3. So I guess just do it one at a time. So
Okay.
so max solver. Yeah.
You could do that, yeah, because you're basically determining which of the answer choices works.
So yeah, right. That's what it always says. The proper one.
You can start in the middle. In the middle is easier. Yeah. So what would you do with C then?
So
Does anybody want to chime in, help out here? Yes.
And 6 is also 3.
It's not going to work because that's going to be a 2, right? This is 2 times 3 to the 10th. That's what that is. Yeah. Jeremy, question there? Oh, you're going to answer it? Okay.
because the answer we also did that deal work because there's a 3
B? Well, the reason why C doesn't work is we want it to equal 3 to the 10th.
Yeah.
And C didn't work because there was a 2 that was sitting there and that was out. That's what that would.
I know that's why he has.
Oh, I thought you said B doesn't. Yeah, that's correct. Is that what you're going to say? 3 to. So yeah, B is the right answer because it says, let me see what it says there. 3 times, which is 3 to the 10th. That is correct on that one. Good. You guys got it. So good. That worked well. B is your best answer right there. Good. Let's go to number 8. Emma, you want to read that one for us?
Sure. If x equals 3 is less than x equals 6, and x is less than 0, and negative 6x is probably considered one possible value.
You have to plug in negative, correct, because it tells us x is less than 0. Well, let's test them out. What can you put in there to verify this? Well, if you did -1, they're equal. So you can't use -1 because they're going to be equal. Well, what happens when it's -2 cubed versus negative 2 to the 5th. Which one's going to be bigger? It is, this is bigger because this is very, very negative here. This number here, and this is slightly negative. So what do you think we can do here? Didn't work with negative 1, didn't work with negative 2, so what do we do now? That sounds pretty good. Which one do you want to use? Okay, so negative 0.5. What happens when we do that?
I know that negative 0.5 could be much, or well, it's going to be closer to 0.
Closer to 0, correct. So I'll make this 1/2 because it's actually going to be a lot prettier. So watch what happens here. Let's make 1/2 cubed negative 1/2 to the 5th. This is easier because 2 is 8, right? Negative 1/8, and this one over here is negative 1/32. And that's exactly what Lucas was saying. This is actually closer to 0, so it's actually bigger. So that tells us the x value had to be a fraction because we knew that it had to be negative, but when we started testing out negative whole numbers, what happened was that it didn't verify this up here, right? This does verify it, so we can use 1/2 as x. What do we do now that we've verified negative 1/2 works as x? Right. And so you get 3. And 3 is the right answer there. Correct. This problem would have worked if you used negative 1/2, negative 1/3, or negative 1/6. No, because it says the final answer needs to be a positive integer. So only negative 1/2, negative 1/3, negative 1/6. Those 3 are the only ones that work. So I saved that one for last because I knew that that was going to take a little bit of trial and error with the numbers for x, but you guys did really well there. You don't. That's not the answer. The answer is, so it's 3, because if you use this negative 1/2 times negative 6, you get positive 3. Yeah. So the only possible answers are when you multiply negative 1/2 or negative 1/3 or negative 1/6 times 6. The answers are either 1, 2, or 3. Okay, great job on that. Does everyone see how that works? One thing that Emma brought up, which helps us here, is if you ever end up with a negative number and it's a grid-in type of question, it's impossible. So you got to go back and work on it because it's impossible to get a negative answer on that. Okay, let's talk about the dynamics of odds and evens. I know you guys have dealt with odds and evens for a long time, but the point behind this is that a lot of times when it is applied to multiplication or exponents, then it's good to know how your answer will turn out. So you got to know the results. So real quick, let's do quick fire on this. We'll go with Dominic. Even, plus or minus even. Okay. Jeremy, back here. Odd, plus and minus, odd. Double check. Even, okay. Lucas, even, plus or minus, odd. Stays odd, okay. Jeremy on this side, even times even. And then Emma, odd times odd. Odd. And then Dominic, odd times even. Even, yeah. Some of these got a little rusty here, even though this is from elementary school, but it's good to know, right? Real quick question, Lucas, which is greater, negative 100 to the 78th or to the 79th power? And?
Oh, wait.
It's positive, way positive. It's like off the chart, you know, huge number. And then the other one is way, way negative, right? So that's how I would look at that. Jeremy Hubinger, can you do number 11 for us? Well, it's odd integer. Yeah, no matter what, they're saying regardless of what odd integer you use here, it's always going to result in an even integer. Lucas, you want to help out?
So basically, or should I try to respond with a
Yeah, explain, or did you, go ahead, just explain.
So basically, you know that all that is going to be, or any number we pick, it has to be odd. And for an odd plus an odd number, it would be the number.
Right.
Eventually it has to be equal to the number.
Right. So no matter what odd you pick, actually, it knocks out A, C, and D immediately because it starts off with just N, which means it didn't change. It stayed odd, right? You want it to be even. And the only one that does that is B because it's, you know, whatever number you chose, 1 plus 1, that becomes 2, right? So B works on that one. This is just remembering the dynamics of numbers. That's really what they're doing. This is an interesting exercise of when you're dealing with positives and negatives. And they're asking you in point C, with regard to that number line, you can pick any number you want for W, X, Y, and Z. What happens when these are raised to powers greater than 1? Let's go with Jeremy Rodenberg. What would you choose for W first as a number? Just pick any value.
I don't know.
You can pick any value for W on that number line. Someone want to pick a value? -2. Yeah, that works. If you square it and if you cube it, that means raising it to powers greater than 1. Is there a trend that you notice here?
Yeah,
Correct. It goes from positive to negative. And as you increase the exponent to larger even exponent, it gets very positive. If you increase the exponent to larger odd exponent, it gets very negative. So that's what we're seeing there. So what I would write down there is when it's square, even exponents, it's greater. Negative exponents, it gets, smaller. That's what, I know it's not much room to write it, but you're kind of writing notes for yourself as to what happens when you square and when you cube or take it to higher powers. Emma, what happens with -1? What's the trend? They give you the number, -1. So there's.
Yeah, I know, I'm talking about -1.
Yeah. So what do you think happens?
I mean, I would guess the same thing.
There's only 2 results. Lucas? Correct. No matter whether it's -1 to the 20th power, it's just going to turn into 1. -1 taken to the 31st power is still going to be -1. So it only does those 2 things. Correct. Dominic, you get to choose. What do you want X to equal and what would happen?
1/2.
Positive or negative? Has to be negative. Then what happens as you raise the powers? It is, and then more specifically, what happens?
I guess it's gonna be, or it's gonna get close to 0.
Yes. No. Both of them are gonna. I'm gonna actually draw a number line so you can see what he's saying here, because this is a weird dynamic of a negative fraction. I know you guys are like, yeah, I have better things to do than think of negative fractions and what happens, but let's do this. -1/2 squared, -1/2 cubed. Let me draw a number line here, but here's your 0. Here's your original number of -1/2. When you squared it, it became positive 1/4, right? And then when you cubed it, it became -1/8, which is actually closer. closer to 0, right? So the trend is actually going, because if you took it to the 4th, I'm going to do that just to show you that. This would be 1 positive 2, it would be 1/4, 1/8, and then it would be 1/16. So this would be 1/16. It's getting closer to 0. As the exponents increase with a negative 1/2, they both, from both sides, they're getting closer and closer and closer to 0. That's what's happening with that. So it's just knowing the trend of where the numbers are going. The rest of it is pretty straightforward. I know you guys know what happens with 0. There's no reason to even talk about that. I know you guys know what happens to 1. Nothing really happens. The only other one to talk about is just that if you chose positive 1/2 for y, then as you increase the exponents, it just gets smaller and smaller and smaller, closer to 0 on that one. Let's go to number 12 here. I'm going to have Jeremy Hubinger read that one, number 12. There are various ways to do this. It definitely is. Does it? Is it? Emma? There you go. Right. Right. And it has to be greater than the original number, so z is the only one. So yes, we could have sat there and picked numbers for it to kind of give it some rhyme and reason, but then looking at the characteristics of these variables, we figure out, oh, it's actually going to be a positive number because we're going to add on this one, and that makes it z. Okay, good. Let's go over here. Jeremy Rodenberg, number 13. You want to read that for us?
If A and B is positive integers, and A equals 16, which is A, 2A is 2 to the power of A is negative B. A to the power of B is 7, where A plus 3B on, and B A plus 5B on.
Which one? Were you just reading those, or were you? Okay. I wasn't sure if you were like telling me which one you're choosing, but go ahead.
So you can, so factor 15 is all, into like 115, 3, and 5.
You can use any of those 4, right?
Yeah. So, which is a following feature for all values of A and B. So you can pick you can use the pairs. Doesn't matter.
It doesn't really matter. They're only using the positive ones, so you don't have to consider negatives at all.
So yeah, so 2 to the power of A is negative. That's not true.
Not true. There's no way that makes it negative. Okay.
A to the power of B is negative.
Not true. Yeah.
Yeah.
Yes, they will never be even. If you took any of them, like A could be 1, B could be 3. It's not going to be. It's not going to be even. And even if you flipped it 3 to the first power, or any of those, it's not going to be even. Okay, next one.
4A plus 3B on. Really wish I was just right here.
Oh no. Well. Okay. I'm going to tell a joke. Well, before I'm going to give Lucas will tell us the answer in a second. But there was once this guy who I tutored, and I teach everything from 8th graders taking the SSAT to high schoolers taking SAT and ACT to people who are going to graduate school to take the GRE, the GMAT, the LSAT. And there's this one dude I taught. His name was Bob. And Bob refused to write anything down. He thought he could calculate everything in his head. And as the math got harder, he would bob his head. And you could tell the math was hard because he would do this. And then it got harder, and he would like really bob his head. And it was like, dude, are you like listening to like some major punk music or something like that? I said, just write it down. Okay. So that's a good reason to carry more pencils. But anyways, Lucas, tell us what happened here.
Well, we already know that an odd and even number when added or subtracted together.
Yeah.
You do an odd number and then number by 4, multiply by 4.
Correct. Yes. So you end up with even plus odd, so it has to be odd there. And that one works really well. That's true then. Okay. Good. Correct. And then D does not work because that's odd plus odd. Odd plus odd does not equal odd. C is your best answer on that one. Okay. Number 14, Emma.
If A and B are both odd integers and C is an even integer, then all the following to be true except.
Yeah.
So they're both odd. And C is even. You can just go through and double check through all of them.
Yeah. Okay. What would you choose here?
So odd.
You can plug in any numbers that fulfill the requirements, which are A and B are odd, and then C is even. But what were you doing with D here?
Or so this is D, so they're always trying to
Dominic, what were we thinking here?
Here's what the answer.
Yeah, well, let's hear how you get there, if you have an answer.
Well, I thought I can see because
Mhm.
I used all the
Rules.
rules, you know.
Yeah.
So it can't be A because odd plus odd equals even, which is true. And then for B, it's odd plus odd. So A times B should be even, which it is because an odd times even is even.
Odd times an even is an even.
So
Right.
B worked, and then
Yes.
C didn't work.
C doesn't work because that's going to be even times odd, which turns into even, and it will never equal odd.
Yeah.
If you use numbers like B was 1 and C is 2, that's going to be 2, right? And there's no way that A could equal 2, no matter what. So answer is C on this one. Oh no, C is the answer. It's the only one that cannot be proven, because if I look at A, 3 plus 1 could equal 4. If C is even, then that's possible. If I look at B and I said 1 times 2, let's try another one. 1 times 4, and I can make A1 B3. That would work, right? C, we already said doesn't work. And if I said 4 minus 1, it could equal 3. So that, or let's make it other numbers. 1 minus 4 is -3. A could equal -3, right? So no matter what, A, C, and D can be proven. I mean, A, B, and D can be proven, but C is impossible to prove. That's what I was trying to say. I'm just looking at number 15, and this version here has not been edited, and so it's not going to give you a proper answer on that. So we're going to skip 15 on this one. That one is a little bit strange there. We're going to continue. You guys did fine here with the math. Any questions on this? Any thoughts on translating or anything like that? We're going to go from there to the writing section. Do you guys want to take a quick break? You guys need air or water or something like that? Okay, let's do that real quick. All right. Yes, let me get there in 2 seconds. Very interesting discussion. I've never heard that movie broken down at an intellectual level, but that was interesting. So I want to get into the next part, which is dealing with the writing section. And I think for a lot of you guys, this is really rehashing rules of grammar that you learned in middle school more than recently. Because in English class now, you guys are breaking down the Grinch at an intellectual level, which is probably what most high schools are doing now. So that's kind of interesting. What they're getting at here with the SAT writing section, for this, we're talking about connections between sentences, between paragraphs, and the use of conjunctions. So the three important things that they're dealing with here are connections between sentences, or transitions between sentences, transitions between paragraphs, and the use of conjunctions and clauses. Those are the three things. So transitions between sentences, between paragraphs, and then the use of conjunctions and clauses, connecting the clauses.
What was the third one again?
Connecting clauses with the conjunctions. So the use of conjunctions and connecting clauses. As you know, there's the dependent and the independent. So to determine the right answer, you got to ask yourself, how are the ideas presented? How do they relate to each other? And some possible relationships that they have are either that they're continuing the idea, contrasting the idea, or else building the idea. So they go from one level to an increased level of whatever they're talking about. So that's just from the context of the sentences. Building, yeah, like it's increasing, like not only was this something, but also it is, something else, right? So it's building. That would be a use of idioms to build it. So that would be an example there. What I want you guys to do, since I think this is not that hard, is you guys can do 1, 2, and 3. We'll go over them together. You guys all ready? Okay. Dominic, you want to tell us with number 1, what did you choose to tell us why?
I chose B.
As a result.
Yes.
And tell us why.
Because it wasn't contrasting. It was it was continuing the idea. It was continuing. The sentence was using what was previous said.
Was it a direct result of? It says, as far back as 200 BC, images of Medusa, the defeated Gorgon abounded, the shield of Alexander the Great, as a result, was graced with the image of the mythical Medusa. Is it a direct result?
Would it be, for example?
For example would be probably more appropriate for this one. So it's, because they're two unrelated events. That's what I would say. So it would be, for example. Let's go to number 2. Jeremy Hubinger, go ahead. Okay, you went with D. Believe it or not, they went with A on this one, and they like that. One of the Gorgon sisters, she'd purportedly known for her beauty. Period. However, she aroused the anger of Athena. That would have been a super long sentence if it was.
Well, it was some reason. It was not that it doesn't
Uh,
count. It's relating, however.
you mean C? C is replacing. C is replacing. C wouldn't work. That'd just be too long, anyways. They went with A on this one. They actually went with A on this one. Yeah. I think from some contexts, however, cannot be used is a continuing conjunction. But I think it's, well, according to the answers, they went with period, however. Yeah, to start the sentence on this one. Lucas, what did you do with 3? That's correct. Yeah, it's contrasting the previous thing. It says people would be turned to stone. Nevertheless, she did meet her end. So she was not immortal in that sense. So good. This is really testing, conjunctions. Yes, Jeremy? It might be because it's long and it's 2 different topics, because it's saying that she's one of 3 sisters. It talks about her beauty, right? And the next sentence is talking about she roused anger with Athena, which is another topic. It has nothing to do with being a Gorgon sister or having beauty. So that's kind of why they separated the 2 sentences.
Well, it kind of contrasts it because it would refer to a monster.
Yeah. Well, yeah, it does contrast it because it's saying beauty in one sentence and then she has snakes for hair. So, good, good. Let's go to the next one. All they're saying here is wordiness. And there's, obvious examples of wordiness are redundancy and repetition, where they're saying the same thing twice, even if it's very subtly done, it's kind of redundant. 2 is too many words. It can be written in a more concise way. And the third one, which is probably the most obvious, is relevance. Because sometimes you'll see something in there and you're like, where in the world did they get this sentence in there? It's okay to omit. Yes. Repetition, redundancy, repetition. Like they'll say something like, every year this happens annually, right? That's redundant. So when you see omit, the underlying portion, it's okay to omit. A lot of students are like, oh no, I can't omit anything. But if something is like clearly out of left field and you're like, why is that even in the paragraph? Take it out, right? So it's okay to do that. It's just not necessary. So that's all you have to ask yourself. Go ahead and do 4, 5, and 6 here. We'll go over these. Yeah, I said ask yourself, is it necessary? Is it necessary? You guys ready? Or I'll give another minute.
I've done a bunch of practice and I've never seen like something like 6 before. Is that a normal thing that I've seen?
Least acceptable?
Yeah.
No, those pop up where they say which of the following? That means 3 of them are acceptable and 1 is not. Yeah, that's okay. Let's talk about number 4. Who did I leave off with on this one? That was the last question was. Let's see. I left off with that was Lucas on that one, right? So, what about okay, Jeremy? What would you do with number 4?
I said, okay.
Yeah, it is redundant because it tells you 5 decades already, and then 50 years, so that's redundant. Correct. How about number 5, Emma? You want me to come back to you?
No, I didn't.
Okay. B's correct. When he was 5, shorter, says the same thing, doesn't lose any meaning to it. That's correct. How about number 6? What do you think of this one, Dominic?
I did.
Yeah. Yeah, because it's exactly redundant. It does. Yes, that's what it is. Okay, what I want you guys to do here is 1 through 10 on the next page. It's kind of like a mini sample of this, and we'll go over it together. You guys ready? Okay, go for it. On the next page. This one, I converted it. It's from an ACT sample, but it's exactly the same. Yeah, that's fine. Yeah. You don't even need to bubble it. You can just circle it right there. You guys ready? Give it another minute or two. All right. Okay, let's start with number 1 here. Lucas, you want to tell us what you got for number 1?
I like it although.
Although is correct here because you're trying to show an exception rather than using since, which is kind of giving a reason for this one right here. Jeremy Hubinger, what about number 2? Yeah, those are the same thing, discontent and unhappiness. Okay, number 3, Jeremy, remember?
I said,
Yes, omit. Number 4, Emma?
I said that is B.
Correct. That is works better on this. Nonetheless, it's showing exception. That is showing example. So it's showing an example on that one. Dominic, number 5.
number 5, I chose B before.
Yeah, because it's just kind of long and wordy. How about number 6, Lucas? Those who is correct. All right. And Jeremy? Omit. Yeah, it's a different story. King Arthur is completely a different story. Yeah. So let's go to number 8. Jeremy, over here. Rosenberg.
I said number 8.
Yeah, number 8. Yeah, this was tricky because it's after years. What's tricky about this is it's not really supported by the rest of the sentence, and it's really asking you to replace a word in there that just doesn't fit at all when it says anyways, right? And the better one is probably in the 18th century because it's very specific, whereas after years is kind of vague. 1 year, 10 years, 20 years, who knows, right? So Emma, the next one, number 9.
I said C.
Yeah, we don't need as kittens. That's too colloquial. It's like eagerly as kittens. It's like, no, it's probably not going to be in the passage. Yeah, no, it's too conversational, too colloquial. All right, let's go to number 10, Dominic.
I chose A.
Yeah, it would not be as appropriate as the other ones. So good. Good job there. I think for most people, the writing section is probably the most logical one, where it's just remembering your own rules of grammar more than anything else. I want to move forward with the reading comprehension, and that way we'll finish the whole lesson on time today. Let's talk again about question types. Today we're going to get into detailed questions, vocab and context, and global questions. So let's flip this up into the passage. Should be on page 76 here. So does anybody remember what a detailed question is? I introduced this last week. It's about the story, facts about the story. What were you going to say, Jeremy?
I was going to say question.
Yeah, so facts about the story meaning like specific words or phrases or key terms. And so that's what they're asking about, specific words or phrases from the passage. They're easy to spot because either they give you a line number, a paragraph number, or a word in quotation marks. Sometimes they'll give you none of those 3. And if they don't give you any of those, when you look at the question, you're really saying to yourself, well, what's the most important word I need to look for in the passage? If they didn't give me a line number, paragraph number, or a word in quotation marks, then you kind of have to reason that out. Okay, so you can spot them usually through line number, paragraph number, or word in quotations. To answer them effectively, you should go back to the passage. I know there's some students who are like, no, I'm really good at reading and remembering. I'm going to say this, as much as we have amazing technology, we do not have photographic memory. Why do I say that? I know that some students are like, no, I remember everything. I say to those students, the only people who can do those are the ones who went to Best Buy, got a Google Glass, and started wearing that, instead of glasses and snapping photos, and were able to review it somehow, or got the special SD card that you can implant into your head with a photographic type of thing, which you can implant into your. Nobody has that, so I would go back to the passage. Okay. So let's spend a couple minutes here. This is a real passage here. And, well, it's slightly shorter. It's only about 70 lines. Most of them are usually about 80 to 100. But read this, and we'll talk about the passage. Okay, go ahead. Dominic, did you have a question?
Yeah, you can, for B, you can spot them because they use them.
Oh, yeah, line numbers, paragraph numbers, or wording quotation marks. Yeah, that's all they have. This is a shortened version just for the lesson. So do that for a minute. Okay, so how would we break down paragraph one? What's the most important thing of just paragraph one? It's an intro. Okay, Dominic, what do you think? Yes. Yeah, significant effect. I would stick with what he said, that it has the main point they're trying to get across is the car had a significant effect. Second paragraph was more what Jeremy said earlier, was that the manufacturing process made it more efficient. Third paragraph, what's the most important thing in the third paragraph? Such as, more specific. Suburbs? What about suburbs? Separation between rich and poor. That's what I would say. That's the most important point. Fourth paragraph, what would we say, Dominic? What would you say this one? How they valued the car? As freedom. More specifically, anybody? Right. So American culture, lifestyle, entertainment, those things were affected by the car. So overall, that fits under what we came up with earlier as an overall purpose. Let's go to the questions now. This is where it's on 78, 79. For the first question, Lucas, you want to read that one for us? In your own words, or look in the passage before you read the answers. This is what I'm trying to emphasize. Without relying on the answers.
I was looking at manufacturing versus like the actual cars themselves. So American manufacturers are both competition.
Yeah.
Europeans are more focused on quality.
Okay.
And so Americans like I don't know what it is. They were talking about like that.
Right. And the Europeans had fewer laborers. I'm sorry, they had a higher percentage of skilled laborers and fewer but costlier cars. Okay. So now I want you to look at the answers. The reason why I was trying to prevent you from just going straight to it is 3 out of 4 are wrong. Right. So now give us yes or no after you read each one.
The American manufacturing process is pretty on efficiency. That is correct.
Okay. So we'll put a yes on that one. All right. And then tell us why the others don't work.
The European manufacturers were able to produce a greater number of cars through those cars. Those cars were quite expensive. That's prices that they produced a lot enough.
Right. Okay.
American manufacturers were trying to change the population distribution of their consumers.
It wasn't the manufacturers who did it. It was the car. So they're kind of pulling info from another paragraph, trying to throw that in there, but it's not. Okay, next one.
European manufacturing process produced cars of notably higher quality. That's correct.
Well, they actually don't say that they have higher quality. They just said higher cost. It said costlier to produce. The word quality is actually not mentioned in that paragraph. It's just assumed. Yeah, like people are like, yeah, I'd rather drive a Porsche. But that's not necessarily what they're saying here. How about question 2 here, Jeremy Avenger? I would go back to the passage to make sure you know what that means in the sentence. 37, 38. Right. Right. Stratification, does anyone know what stratification, stratify? Yeah, have you heard like clouds, the stratus clouds or higher clouds? That's what they were talking about there. So now give us yes or no on these answers here. C and D are never mentioned. There's no mention of farmers, no mention of job satisfaction. Those are just way, way out. And B doesn't make any sense. The tremendous expense, never mentioned. A is your best answer on that one. Okay, we have the same passage. We're going to be talking about vocab and context. And what they're saying is vocab and context ask about a specific word and its contextual meaning. Like it may mean something else from its face value, but when used in context, it has a different meaning. So they ask about the contextual meaning of a word. Okay, you can spot them because they have one-word answers. This is where it's very, very obvious. B, you can spot them because they have one-word answers, and you know that it's not going to be the face value. They're always going to give you one trick answer that is the literal definition. So I would definitely go back to the passage. Make sure you know what they mean by that. It's usually a inferential meaning of that word. It's not really a literal meaning. So that's why I want to go back to the passage. If you're not sure of how to do it, you can read that sentence 4 times with each of the answers and see which one gives you the best meaning of that passage, of that sentence. So let's look at this first one here. Go back to the passage and read that sentence. You could use each of the 4 words if you can't figure it out. So you can see that both of these have one-word answers, but don't go with the literal here. Let's go with number 28. Let's go with Jeremy Rodenberg on this one. Number 20, line number 3, line 28. Are you on the right page? You're not. Why don't we go to Emma for this one?
Has ours became more? Oh, you want me to read?
What question are you on?
Okay.
Oh, you're reading a sentence. Okay.
In line 28, down both and then if you go back.
Yeah.
As cars became more popular, their effect on the population.
All right.
Was likely profound, which means, we have a big deal.
Big deal. Okay. So what's your best answer here?
I think.
Far-reaching. Yeah, and the passage kind of talks about that with people moving, people's lifestyle. So that's the best one. The word absolute is one that a lot of students choose, but absolute means all or nothing, right? So that's not really what they're saying with that. How about number 4, Dominic?
Yeah. In line 66, afforded most nearly means, and the sentence is, this personal mobility and autonomy afforded by the car is becoming an integral part of America. It kind of means like given or like because of the cars.
Yeah.
Because of the car.
Yeah, exactly.
Bonds, no. Reduced, no. Acquired, maybe, but probably not. And provided, I think. Provided. I think provided.
That's correct. Provided because the car physically didn't buy or acquire anything. It just allowed humans to do these things. So that's your best answer on that. Good. This part here, we have almost pretty much answered already because global questions deal with the passage overall, and they ask about the primary purpose of the passage. So they ask about, they'll use the words, what's the primary purpose? What is the main idea? Those are the classic ways in which they construct that question. So they ask about the primary purpose, the main idea. You can spot them because they use those specific words, primary purpose or main idea, and they usually will not refer to any line number or paragraph number, so you know it's dealing with a passage overall. And to answer this, I would identify the purpose while you read this passage for the first time, because when you read a passage and you don't come away with an overall purpose, then it maybe did not, the message of the passage may not be fully expressed. That's what I would say there. For this, Jeremy gave us the primary purpose. I'm going to go back to you since you gave us this, Mr. Disrupt. Okay? And how would you answer number 5 here?
The primary purpose of the package is to review and get a commonly held belief.
Yes, no, or maybe when you do that. Don't just read the next one.
No.
Okay.
The really free of the adventure. Yes.
Okay.
The what is that? That's the development. Also, yes, the argue for perfection now, so I guess between B and C.
Mm-hmm.
So, I think it's C.
It's C. Now, when you had yes and yes there, what gave you the confidence in C rather than B?
Because although it kind of relates to the history of the invention in the first paragraph, which is why I said yes to B also, it further explored the consequences of it.
Right, the effects, yes, exactly. B would have been more correct if it talked about, like, who's the first person who created cars in America and how he created the Model T Ford and all that kind of stuff. But it really didn't go into all that history. It really dove right into how cars affected American life. So that was correct. Let's go to 6. Emma?
Based on the passage, the author would regard the changes brought about by the automobile as
Don't read the answers. Put that in your own words before you read the answers.
I say that they would regard the changes as positive and negative, but a really big thing.
Okay, that's good. Both positive and negative, a really big thing. Now go to the answers.
A, more permanent than those brought about by other 20th century causes.
Yes, no, or maybe.
No, they didn't mention anything about it.
Good. All right, next one.
Far-reaching and extent in both positive and negative effects is basically what I said.
Yes. Okay.
So I go with
D. And just for the sake of saying no to C and D?
just because I understand the word investigation, they investigated it.
There wasn't really anything difficult to understand about it, right? Okay.
Larger negative and a sound. It wasn't a sound influence, but they also mentioned positive.
More positive than negative. Yes. Question, Dominic?
For C on the previous page 85, to answer them effectively.
You must identify the purpose when you read the passage for the first time. Because it, like I said, if you read the whole thing and you came away with nothing and you're kind of like, I don't really know what this was about, then that did not truly sink in. Before we close up, we still have a couple minutes. I want to talk about one thing here with global questions. Did I mention this last week where I talked about classic purposes of a passage? Did I talk about that or not? I said, like, described is one of the most common ones. Like almost 80% of the passages fall under described. Did I talk about that? Okay, let me just write these on the board here. Since we just talked about global questions, here's some classic purposes. Describe. Did I talk about this? Compare, reuse, propose. Narrate. So, 7. Did I mention this? I don't know if I did. Maybe I did, maybe not. Maybe I did. But like 80% of the passages are describe, explain. They're neutral passages like this where they introduce something from history. Compare, contrast. Once in a while, they'll have something that'll show you two different perspectives. Some scientists believe this, some scientists don't believe it. This is the conclusion. I did mention this, right?
Yeah.
And then I said, propose and recommend. Usually when there's two paired passages, one of them will propose, the second one will defend or refute the first perspective. So that's why I paired these up. Narrate, all the fiction passages, they're narrating, that's their purpose. And then analyze, usually a scientific or something will analyze or critique. These are pretty much the 7 classic purposes. So we don't really need to think that hard when we're thinking of purposes. They pretty much fall under this. The question that Jeremy read earlier, if you looked at the first words for number 5, it's refute, relate, explore, and argue. You could knock out the refute and the argue immediately. Because this guy was more of a neutral writer. He wasn't really trying to argue or prove a point on this. He's just explaining how cars affected us. So that's kind of what that is. You guys did a great job today. I think you guys handle all these topics really well. For the homework, if you want, I'm going to give you guys 2 options. One is you can turn them in and I can grade them, or I can send you guys the answers every week and you can look over them. What would you guys like?
I prefer to
I'm sorry?
I prefer to
So I can send you the answers? That way you don't have to turn it in every week like that? I'll do that. Okay. And then just a reminder, this Saturday, I know some of you guys might be taking the real test. Is that all right? This Saturday? I heard that from, okay. Our practice test here on campus is 9 to 1. And some of you guys need extra time. What I'm going to do for those on extra time is just so I don't hold you here forever on campus, the essay you can do it at home. And for you guys who are on regular time, the essay you can do at home. That way you can just, because the essay part I think is it is graded on the scales of 1 to 4, but I think most students, they're exhausted by the time we get to the essay. They're like, let me go home. Okay, unless you guys want me to time the essay here. Okay, that's consensus. All right, Dominic, you
I mean, I would like to, but
okay. Well, you can. Yeah, I'll do that for you. Those are on extended time. I think you probably. I don't know who's on. You're on extended, right? You're on extended. I'll time it for you. Okay.
I mean,
For
you
you
can time it at home.
Yeah.
You just go to the time.
For you guys, I'll let you do it at home because you guys are way longer.